So children, in the part 1, we have discussed the need of measurement. And you learned why do we need measurement and what are different system of units that are available for measurement. And what is SI system that we finally wish to use and a more standard system. And what are different component of SI system and how to convert also the values from one system of unit into another system of unit. What are fundamental units, what are derived units. Here, we are now in part 2 of this chapter, we will be talking about how to measure. Measurement of length, mass and time. How to actually measure. Now the point is that in order to measure, we have some direct method and indirect methods. The reason is, we cannot use always direct or indirect method. Say, I take a situation, say you wish to measure the height of yours. You can use a scale. Say, you wish to measure the length of the cricket bat or hockey that is available to you. You can use a scale. But in case if you measure the gap between Earth and the Moon, the gap between Earth and a satellite, the gap between Earth and Sun or any astronomical object, we cannot use a direct method. We do not have any scale which can be put for these measurement. There we need indirect measurement. So this chapter, this second part of chapter 1 is about direct and indirect method of measurement. Before moving into detail, the one thing which I wish to introduce before is order of magnitude. Now this order of magnitude we use in physics a lot in order to give a closer description of the measurement done. For example, if I say charge of electron is 1.6 into 10 to the power minus 19 coulomb. So I would say the charge of electron has order of magnitude, its magnitude has an order of 10 to the power minus 19. So the closest power of 10 that we describe here. For example, I can take the case here, mass of electron. Mass of electron is 9.1 10 to the power minus 31 kilogram. So the closest power, because this 1.6 is less than 5 and this is closer, so I can write it, it's approximately, I can write order of magnitude of mass is 10 to the power minus 30 kilogram, because I take it near or approximately 10. So 10 into 10 to the power minus 31 will be 10 to the power minus 31. So order of magnitude is the nearest power of 10 that can be used to represent that value. For example, if I say the distance between Earth and the Sun is say 1.66 into 10 to the power minus 11 meter, 10 to the power 11 meter. So order of magnitude I'll say is 10 to the power 11 meter. So that nearest power of 10 which we are using is in fact giving us a closer idea of that size, of that mass, of that time. For example, the time interval somewhere you are writing, the time interval is say 5,000 seconds. So I will say order of magnitude is 10 to the power 3. Or mass of an object is 6,400 kilogram. So I will say order of magnitude is 10 to the power, say 6.4 into 10 to the power 3 or 10 to the power 4 kilogram. That's how we just give a closer description in the form of order of magnitude. So finally, this formula. Let us now learn how the order of magnitude of physical quantity would be decided. Say we have this value, measured value. It has a value n into 10 to the power x. Now, if n has a value less than 5, then order of magnitude would remain x only. So n doesn't make any addition to the order of magnitude, where if n has a value more than 5, then order of magnitude has an addition to x by 1. So order of magnitude is x plus 1. We learn that in case if n has a value less than 5, then order of magnitude has no addition, and if n has a value more than 5, then order of magnitude has an addition of 1. Now here this table is giving you some more examples. We have a value 3. Now 3 into 10 to the power 0. So order of magnitude is just 10 to the power 0 or 0. 3 being less than 5 doesn't make any addition, where 9 into 10 to the power 0 should be, in fact 9 would be being more than 5, so order of magnitude is 1. Similarly, in this second value 5.2 into 10 to the power 1 or 52, here this being n being more than 5, the order of magnitude is 2. Similarly, 62354, this is the value. So I write 6.2354 into 10 to the power 4. Being n more than 5, the value of order of magnitude is 5. Same way, we have other value 0.018. Now, if I write it 1.8, I should say 10 to the power minus 2. But this being less than 5, order of magnitude is just 10 to the power minus 2 or minus 2. In other measurement, 1.67 into 10 to the power minus 27. 1.67 has a value less than 5, so order of magnitude would remain just 10 to the power minus 27 or minus 27. So all these gives you a clear idea how the value of n makes a decision whether you should add or you should not add. Here I have another table. Size of universe is of the order of 10 to the power 25 meter. Now we will not always be writing the exact value 3.777 into 10 to the power 25 meter. No, just 10 to the power 25 meter. The size of universe is of the order of 10 to the power 25 meter. Similarly, size of Milky Way galaxy is of the order of 10 to the power 21 meter. Distance of nearest star from Earth is of the order of 10 to the power 16 meter. Distance of Sun and Earth is of 10 to the power 11 meter. Distance of Moon from Earth is of the order of 10 to the power 8 meter. So it gives an approximate idea of the gaps. Like radius of Earth is of the order of 10 to the power 7 meter. Height of Mount Everest is of the order of 10 to the power 4 meter. Thickness of sheet of paper is of the order of 10 to the power minus 4 meter or of the order of millimeters. Tip of a sharp pin is of the order of 10 to the power minus 5 meter. Wavelength of light is of the order of 10 to the power minus 7 meter. Size of hydrogen atom is of the order of 10 to the power minus 10 meter, and size of a nucleus is of the order of 10 to the power minus 15 meter. So this gives you an approximate idea of those very large or very small distances, which you can not always remember and write exactly. But still, you wish to have a comparison of hydrogen atom size and nucleus size, you can say 10 to the power 5 times is the size of atom as compared to its nucleus. If you can compare the radius of Earth and the distance of Moon from Earth, so you can say the distance of Moon from Earth is 10 times from the radius as compared to the radius of Earth. So that's how you can always quite closer comparison between the two things with the help of this order of magnitude. Coming to when we are interested in the measurement, we have some situation where we can do direct measurement, and we have some situation where those direct measurement are not possible. Here I have taken the case. In case if I am measuring a length from say 1 millimeter to 100 meter. So if we are measuring the length from 1 millimeter to 100 meter, a scale would do the job for you. You can use a meter scale for that, from 1 millimeter to 100 meter or a little more, but still. In case if you wish to measure a distance more than 100 meter, you need some indirect methods. Similarly, we do have some more direct instrument for measuring distances less than 1 millimeter, like this vernier calipers, 0.1 millimeter. If a length, if you have a size of the order of 1 millimeter, 0.2 millimeter, 0.7 millimeter, like that, their vernier will help us. We can use this direct measuring instrument. Then, in case if we are looking for even smaller length of the order of 0.0 meter, we have screw gauge and a spherometer. We will be talking in detail about all these instruments, part of your practical experiment also. So there we have all these instruments. But in case, when we have to find the gap more than 100 meter, say few kilometers, we have to find a distance 100 kilometers or even more, we need indirect measurement. For example, you are standing in front of a big mountain and you wish to measure the distance between and the mountain. So you are standing here and there is a mountain at a gap and you do not have a scale with you, or even that scale is not able to serve the purpose because the gap is too much. There we are going to use echo method or reflection method. Now what is that reflection method? We know sound has a speed 332 meter per second. So what you can do is, you can produce sound here, you can produce sound waves here. These sound waves will reach here, will reflect. And what you need to know is the time gap between ending, because once you produce sound, the sound produced would directly reach to a ear as well as will travel forward. And after reflection, the sound comes back. You can just know the time gap. You know the time and you know the speed of sound, 332 meter per second. Now imagine the gap is of sound v, and it has taken a time t. between producing the sound and receiving the sound. Can I say it is 2b? Velocity into time will give you the distance. But in that time t, it has traveled a distance b and it has come back a distance b. So this v into t is 2b, and gap between you and the mountain would be velocity into time by 2. So you can calculate the separation. You can calculate the distance between you and the mountain. Similarly, I come to another case. It's a similar way. And it's a laser to know the distance of moon from earth. Now, in case of moon, if you are interested to use echo method by producing sound, it may not work. Reason is, of sound you need atmosphere, because sound is a wave that travel through the atmospheric particles. You need a medium. Between earth and moon, there is no medium at a larger part. So sound wave would not travel the moon. And also you may not be receiving back, even if it would have traveled, it would have taken a lot of time. So in case if we wish to measure the distance of moon from earth, we have another option, which is laser. Laser beam or radio waves, they do not necessarily need, they do not need a medium to travel. So and they travel with the speed of light. So laser, which is, if we say, how do we define laser? So it is light amplification by stimulated emission of radiation. So laser is basically light amplification by stimulated emission of radiation. Ultimately it is what? A radiation, a strong radiation. Now laser beams travel at the speed of light and it is monochromatic. Monochromatic, it means one wavelength, one color, and it travels with speed of light. So a laser beam, which is quite intense, is sent to moon and it certainly will reflect back and will be received. So if the gap is b, we can say c into t. C is the speed of light, speed which which the laser beam travel, and it has taken a time interval t is equal to 2b. So the separation is c into t by 2. So in case of measurement of distance of another astronomical object like a satellite near Earth, which is quite far, or maybe any asteroid, you can use laser beam to find its distance. And ultimately it's an echo method. Similarly, coming to another one, and this radar method. Now radar is also an electromagnetic wave. It is used for radio detection and ranging. Radio detection and ranging. So in radar also, the transmitter, here in this disc you have a transmitter as well as a receiver. A transmitter produces strong electromagnetic wave, and these strong electromagnetic waves are reflected and coming back. So again, if the gap is b and the electromagnetic wave travel with the speed of light, so you can say c into t. If time interval between the receiving and sending of signal is t, c into t is 2b, and the separation of that aeroplane may be c into t by 2. And if you wish to know the speed of the plane, you can find the distance, say at for one moment the gap was b1, next moment within a time interval the gap was b2, and then by finding the the gap at different time interval, we can find its speed also, angle also. So with more detailed understanding of the distances, the angle angle at which the distances are changing, we can exactly find the location of it, the speed of it, and the angular displacement of this plane also. So that's how radar method is used for finding the distance of plane coming towards you. Now coming to the next one, there is another method, sonar method. Now this sonar method, because these electromagnetic waves may not be that helpful in finding the object in the sea, in water. There, ultrasonic waves which travel with the speed of sound are more useful. So these ultrasonic waves, particularly this word is sound navigation and ranging. So imagine you are on a ship and you wish to know about the depth of the sea, or you wish to know about anything which is under the ship. It may be a submarine, it may be any other object. You wish to know whether it exists and how far it is. So there we use ultrasonic waves, which are basically sound waves or frequency more than 20,000 hertz, to know the depth, location, and that is done again by echo method. These ultrasonic are sent, these ultrasonic waves are sent, produced and sent, they reflect. So they are traveling with speed of sound, and speed of sound will differ as per the medium. So in air, speed of sound may be 332 meter per second, but in water the speed of sound is higher. So we use that speed of sound in water into time interval, and we can say it is approximately 2b, and the b would be velocity into time by 2. So the point here is that in water, ultrasonic waves are more successful in measuring the depth of an object or location of an object. So depending on the need, we choose different waves for finding the object using echo method. Now this is another example of echo method. Radio waves know the thickness of a meter sheet. So just imagine you have a meter sheet. You have a sheet, it may be, and you wish to know the exact thickness of it. Or maybe you want to know that if there is some crack in this material sheet. What you can do is, over this side, on one side we do the polishing, so that any wave that is sent is reflected back. Now radio waves, a pulse of radio waves is sent, pulse of radio wave is sent, and time interval between the sending and receiving is noted. Here the time interval would be small, so you need very sensitive instrument for finding exact time. It may be nanosecond, it may be microsecond. So you know that radio wave is c, speed of light, into time interval, it will give you 2b, and the thickness of it can be c into t by 2. So radio waves are also used to know the thickness of a meter sheet. Now coming next.